Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now got to question number 9, which is the final question from this Pure Mathematics P3 International A-Level Edexcel June 2022 paper. And this question here is about this curve with the equation y equals 1 plus 2 cosine x all over 1 plus sine x, where x must be between minus pi over 2 and 3 pi over 2. The point M shown is the minimum point on the curve, and we have to show that the x-coordinate of M is a solution of this equation. Okay, so a minimum point on the curve. Now, a minimum point means the curve turns at that particular point. So that means the gradient of the curve at that point is equal to 0. So we know at M, we know that dy dx is equal to 0. So we have to find what dy dx is. Now here we have a quotient of two unrelated functions, so we cannot use, for example, the chain rule or anything to differentiate this. We have to use the quotient rule here. And the quotient rule is set up in a very similar way to the product rule. The numerator we call u, but here we have to call the numerator u, don't have a choice. And v is the denominator, which is 1 plus sine x. And we find what the differential of u is, so we find what u dash is. Now u dash is equal to, if you differentiate 1, it becomes 0. Differentiate 2 cosine x, you get negative 2 sine x. And if you differentiate 1 plus sine x, well, 1 becomes 0, and sine x becomes cosine x. Alright, now when you're using the quotient rule, you multiply v by u dash and take away u times v dash, and then divide by v squared. That's the quotient rule is v u dash minus u v dash over v squared. I think they give this to you in the formula book anyway, but I always set it up like this: u on the left, v on the right, and the differentials underneath them. And I always go from right down, diagonally down across. Start with that one: v times u dash minus u times v dash. Okay, so you're going to have to multiply these two together. So you're going to have minus 2 sine x times 1 plus sine x, take away, and you're going to have cosine x times 1 plus 2 cosine x over v squared. V squared is 1 plus sine x, so 1 plus sine x, and all of that is squared. Okay, so this is dy dx. And we know that dy dx equals 0, so this has to equal 0. So I'm going to start simplifying this as I also make it equal 0. So this is minus 2 sine x and minus 2 sine squared x. And you have minus cosine x and minus 2 cosine squared x. I'm going to leave this as it is for now. That's 1 plus sine. Let me just make that a bit neater. Okay, and that's over, I'll keep this as it is, 1 plus sine x all squared equals 0. Okay, equals 0. Now, I can multiply both sides by 1 plus sine x all squared. That gets rid of the denominator. And then I'll be left with basically 2 sine x, minus 2 sine x, minus cosine x. And you have minus 2 times sine squared x plus cosine squared x. See, these two, I can take out the minus 2 as a factor and write it like that, and you'll see why I've done that. This has now got cancelled out, so I'm left with an expression that looks like this. Now I know that 2 sine x squared plus cosine squared x equals 1. Okay, I know that's true, so I'm going to have minus 2 sine x minus cosine x equals 2, and we got to show almost the same thing, just multiply both sides by minus 1, and we're left with what we have to show. Therefore, we can say that 2 sine x plus cosine x equals negative 2. So that's what we were required to show. Okay, so simply just using the quotient rule and just simplifying it and remembering that sine squared x plus cosine squared x equals 1, we can then simplify this to what was required. Now, we've done part A. Supposing you couldn't do part A, don't just give up and not look at the rest of the question. Part part B. It says here, hence find to three significant figures the x-coordinate of m. So basically they gave us the equation that we have to solve to find the x-coordinate of m. This equation, when we solve it, that will give us the x-coordinate of m. So if you know how to solve this equation, you can get those 5 marks without losing any of them. Okay, with any of these 5 marks. All right, so don't give up on part A. Maybe you don't know how to do part A, but part B is accessible to you to do, and all those marks are accessible because you've got the exact equation as you're supposed to have it. But that also means that when you're doing part A, you have to make sure you show all your steps carefully. You can't just start off with something and end up write all sorts of nonsense in between and then say, therefore, you know, this is the answer. No, you have to show your steps carefully and clearly. All right, otherwise you're liable to lose some marks from that. So that's one of the drawbacks. But one of the advantages is if you can't do part A, part B is still accessible to you. So we have to basically solve this equation. 2 sine x plus cosine x equals -2. Now to solve this equation, this is one of those type of equations. You don't have sine squared, you don't have a cosine squared. You can't make it to a discrete quadratic very easily in that sense. All right, so you can't use that. They're the same angle, so you can't use the, you know, what's called the factor formula where there's different angles there. So this is the type of question where you have to use this form like r sine x plus alpha, or you could use even r cosine x plus alpha, something of that form. This is the type of question, and you can see that this type of question didn't come up in the whole of this paper so far, and this always comes up. So this question, you know, you should be suspicious by the time we got to the last question. Hold on, you know, haven't had to use r cosine x plus alpha or r sine x plus alpha, and P3 always has that, always, nearly every time. So that should be in your mind when you get to this as well. Hold on, I haven't used that, and this is a classic case of us having to use it. If it said equals 0, no problem. We could use you know, the tangent ratio. All right, we could use the tangent ratio, and we could have put, you know, 2 sine x equals minus cosine x, and then divided by cosine x, and we're left with a tan x equals. But we can't do that here because you have a number here. All right, so you can't do that. You can't. If I divide by cosine x, I'll end up with minus 2 over cosine x, and 2 tan x equals that, and it won't be very easy for us to solve in that way. So what we need to do is to rewrite this. Now we could rewrite this in 2 ways actually, but the way it looks here, we could use r sine x plus alpha. That form will give us something like this, because if we know from our factor formulae, from our addition formulae, which I'm going to bring now so you can see them. Okay, so these are the addition formulae from the formula book. So we can see we want something that has sine and cosine. Okay, sine first, then cosine, so it's going to be something like this. And we want a plus between them. So sine something plus something. So sine x plus alpha. That's going to give us something of the form that we require. Okay, so if we can say, let's r sine x plus alpha be the same as 2 sine alpha plus cosine alpha, then we can rewrite this in this form. Okay, so if we do that, we have 2 sine alpha plus, sorry, 2 sine x plus cosine x, alpha x, 2 sine x plus cosine x. We want to write it in that form. Let me just correct that here. That's 2 sine x plus cosine x. So we're going to have here 2 sine x plus cosine x can be written in this form, r times, I'll have sine, now r times the sine of, if I expand it, I'm going to be using this one here, sine A cosine B. So this is like your x and this is like your alpha. We're using the plus part. So it's sine A cosine, and it's going to be alpha. This is like our A, this is like our B. Cosine alpha. Okay, plus, then we'll have cosine A. So this A is going to be like our x. Sorry, so that's sine x cosine alpha, and cosine x sine alpha. Okay, cosine x sine alpha. A is x and B is alpha. A is x and B is alpha. So this is going to be given in this form, and the r is multiplied by both of them, because I've got the r times all of this whole thing, which is expanded, right? So r times sine x cosine alpha plus r times cosine x sine alpha. That's how this can be written. And now, why are we doing that? Well, what we can do here is we can find the value of r and alpha using comparing coefficients. So if we take all of this and we compare the coefficients. Let's just make a bit of space here. Okay, if we compare the coefficients, so for example, if I compare the coefficients of sine x, if I compare this coefficient on sine x, on the left hand side I have 2. On the right hand side I have r cosine alpha. So 2 must be the same as r cosine alpha because these are identical to each other. So 2 is the same as r cosine alpha because you have 2 sine x. So r times cosine alpha must be x, must be 2. And here you have 1 cosine x, and here you have, oops, the r must go over there, r cosine x sine x. So here we have r cosine x sine x, so cosine x and r sine alpha. So we can compare the cosine x's, and we have on this side 1 cosine x, on this side we have r sine x cosine x's. So now we have these two equations. Now I can solve this for alpha, and I find what r is, and there's a nice simple way. I like to use this triangle. I say, okay, let's make a right angle triangle. Okay, let's call this angle alpha. Okay, from this first equation we can say that cosine of alpha is equal to 2 over r. And from the second equation we can say the sine of alpha is equal to 1 over r. So the cosine of alpha adjacent over hypotenuse, the sine of alpha opposite over hypotenuse. So we can see that r, by Pythagoras' theorem, is equal to the square root of 2 squared plus 1 squared. So r is equal to the square root of 5. And we can also see that to find alpha, we can say, okay, the tangent of alpha is equal to 1 over 2. So alpha is equal to, now we have to use radians here, x is in radians. So I've got to take the calculator and make sure that it's in radian mode, which it is. Okay, it's in radian mode, so I say inverse tangent of a half, 1 over 2. And I write down that value, it's 0.4636. I'll write it to the 4 decimal places for now, for SF. So alpha is equal to 0.4636. 0.4636. Okay, so what we can therefore say, we can say that 2 sine x plus cosine x can be rewritten as the square root of 5 times the sine of x plus 0.4636. Now what I'm going to do is I'm going to store this as a. Okay, so this is stored as a. So alpha is a in my calculator. I've just kind of made a note of that. Okay, so there's okay, something that's going to help us now, because now we can therefore say, you know, as we know, we're trying to solve the equation 2 sine x plus cosine x equals -2. Well, 2 sine x plus cosine x can be written in this form. So if I can now say the square root of 5 times sine of x plus 0.4636 is equal to -2. That solution, the solution to this is the same as the solution to this. And I can solve this very easily now, because I can just divide both sides by root 5. So the sine of x plus 0.4636 is equal to -2 over root 5. So I can say now x is equal to, or x plus 0.4636 is equal to, now I have to be careful about my angles. They have to be between, this is minus pi over 2 and 3 pi over 2. So I have to not include angles that might not be acceptable in this range. So let's have a look what we have here. We have to change this limit to x plus 0.4636, which I've stored as a, and therefore I have to do minus pi over 2 plus 0.4636, and I have to also have 3 pi over 2 add 0.4636. So my limits have to be these. So I'm going to just find out what the limits are. So I have this, okay, and I have to add this to negative pi over 2. So let me add this to negative pi over 2. Or it's the same thing as saying this minus pi over 2. Okay, because it's taking, it's the same thing as this minus pi over 2. And that gives me negative 1.1071. So negative 1.1071. That's as far as I can go in this direction. Okay. 4636. And in that direction, I can go as far as 3 pi over 2. 3 pi over 2. And I have to, again, take away, no, I have to add, sorry, to add 0.4636, which we stored as A, which we, one second, get rid of that, which we stored as A. So recall A, that gives me 5.170 or 5.176. That's as far as we can go. We can't go further than that. We can't go less than this. So now, when I press inverse sine, I'm just going to inverse sine of negative 2 over root 5. Okay, I'll get my solution. So x plus 0.4636 equals. So I'm going to take negative inverse sine of negative 2 over root 5. Okay, that gives me negative 1.10. Give me exactly this value here, 71. Okay, so now if I do minus 1.1071 minus 0.4636, well, I'm going to get negative pi over 2, aren't I? Because, okay, I'm going to store this answer because I might need it as well as B. All right, so that answer is now B. But if I take away from this answer that I stored as A, so I'll recall A, okay, you see we get minus pi over 2. So this is not going to be acceptable. This answer is going to be, so that's going to give you x equals negative pi over 2. Now, x equals negative pi over 2 is out of our range because it has to be greater than that. And this is equal to that. So this is not acceptable. All right, so we have to take another answer. Now, for sine, the other answer is you have x plus 0.4636 equals, we're going to do pi minus this answer. For the sine, to find the other answer in the range, we've got to take away this answer. So it's pi minus 1.1071. That will give you the other solution, because the solution we just found, okay, was over here. Sine curve. We just found something here. We need the other solution, which is 180 minus this value, which is going to give you the angle over there. Okay, so if we take pi and we add this value to it, so I'm going to take pi, and I'm going to, I'll just do the same thing, minus the answer that we got, and we stored it as B. So shift recall, you see B is exactly that, minus 1.1071. We stored it as B, so I'm going to press B. So pi minus B, pi minus this is going to give you 4.2487. So you're going to say x plus 0.4636, x plus 0.4636 is equal to, you got 4.2487. 4.2487. So therefore x is going to be 4.2487 minus 0.4636. So x is going to be this answer minus, okay, what we stored as A, minus recall A, 0.4636. Okay, so the answer minus A, and that will give us 3.7850. 3.7850 continues. Now we want the answer to 3 significant figures. So x equals 3.79, x equals 3.79. That is the x coordinate of M. Okay, now that's you know, how to deal with such a question. There's a bit of a tough one here, because to solve this equation you have to think a little bit. But remember this when you have like sine and cosine without any of them being squared, then you know, and it's not equal to 0, in which case you'll be able to just divide by cosine x and get some tan x equals some number. Then we can use this method where we change it into r sine or r cosine. We could have also changed it into r cosine x minus alpha, because that would have given us r cosine x cosine alpha, and we would have got minus r sine x sine alpha, and we would have ended up in the end with the same answers. Not the same value of r and alpha, but the same answers in the end. It will give us the same thing, because that can be written as cosine first and then sine, which would be of this form. Cosine A plus B, because cosine A cosine B minus sine A sine B. It would give you exactly the same answer. Okay? And I can actually show you that it would give you the same answer if... I guess I will do that. For those of you who've understood, that's fine. And I want to show you before that I do that also that we've got the correct answers. If you have time and you want to check, in case you made a silly mistake, you can check that we got the right answer. So I'm going to store this answer that I got, the final answer. I'm going to store this. I'm going to store this as A again, just as A. And the other answer we got was negative pi over 2, which doesn't solve our equation. Well, it solves our equation, but it's not a valid value. So we can check to see even if that was true. So if we put instead of x minus pi over 2, it should give us, in this equation, should give us negative 2. So 2 sine negative pi over 2, close the bracket, plus cosine of negative pi over 2, and again close the bracket. Now if we're correct, this will give us negative 2 as an answer, and it does, so we're correct. However, we can't include this answer because our limit was x must be greater than negative pi over 2. So this answer would have been rejected, as we did reject it, because it's right on the limit. So you've got to be careful about it doesn't have the equal sign. Alright, but what I'm going to do now, we've saved that final answer as A, so I'm going to replace that with A. Okay, I'll replace that with A. Okay, and here, the same thing. I'll replace all of this here with A. So shift, recall, this was A, remember? That was my answer, 3.78 in the end. Okay, I rounded to 3SF, of course, here. So I'll use A again. So that's now put that angle in its exact form inside our equation to see if it solves it. If it solves it, if that value that we got is correct, then when we put that value in here, it should solve this equation. It should make this side also negative 2. If you press equals, it gives us the right answer. So we can use a calculator to check our answers are correct, especially if you have exact values. And that's one of the benefits of using this storing and recalling function of your calculator to help you to check. All right, so we know for sure the answer is correct. Okay, so that concludes this question, which is question number 9 from this paper, which is June 2022. And this question was to do with trigonometry and also differentiation, and also it was to do with solving trig identities and equations. Okay, so other questions from this particular paper will be found on the playlist that will appear somewhere in this region over here. You can click the link over here. You can click the link over here, which will take you to the playlist that involves, let's say, differentiation from P3, and here I'll put the playlist that involves trig identities and equations from P3. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.